Hello everyone. In this video, I will be discussing on how a opcode fetch, execute, and t-state machine cycle will be running out, and what is the respective timing diagram we'll be discussing in this video. Coming to the objective of this lecture, this will be helping you to gain knowledge in 8085 microprocessor timing diagram. Coming to the first one, let's take an example of moving a data from B register to A register. This is an instruction which has been written at an address of A000H. So this instruction opcode would be like A78 is a hexadecimal opcode for moving a data from B register to A register. And this corresponding value is being stored into the memory location A000H. Okay. So that is nothing but when you are referring to the memory location, this is the opcode fetch cycle you need to have it up. So here you need to fetch this one automatically. The internal process we have shown in the previous video that this will be done. So for this particular example, you would be having only one opcode fetch cycle, nothing else. So the opcode fetch cycle or the different cycles would be represented like this. So this one I have shown with the clocks of the 4 clock cycles. It will take it up. This opcode fetch. We will be concentrating on usually onto the 5 different waveforms. That is nothing but obviously these two are considered as a one waveform. Lower order, higher order address bus and higher order address bus. Next one is ALE, stands for address latch enable. Read bar, write bar, IO or memory bar. So these are the different five. What we can say is that as we are considering these two as the two separate entities, so these 6 waveforms we need to count. So coming to the first one, opcode fetch, how it is going to read. In the first clock period, the address is being sent on to the address buses. So as you know that we are having 16-bit address bus and 8-bit data bus. Now this 8-bit data bus is the lower order address bus as well as data bus. So at the first clock, it would be purely used as an address bus. So this address, as you know this one, out of this address, what is that address? A000H. So this one 00 is the lower 8 bits. So lower 8 bits has been sent on to these lines. And the higher 8 bits are sent on the upper lines. So this value is been sent in the first clock. Then the address of the memory from where it need to take a data, that would be confined in the first clock. Then immediately address latch enable signal would be high. That moment these values will be taken up. And next one, after this one, what we need to do? We need to read the data from the memory location. So to reading a data from the memory location, we will be making this read signal as a low. When you make a read signal as low, what happens is that immediately it starts reading a data. And next one is whatever the data is there that has to be read up, this is the thing you will be having. So most probably the reading operation will not start at the immediate instant. And address latch enable for all the timing diagrams, it would be constant. For the first clock only, it would be high. Remaining all clocks, it would be low. This is about the address latch enable signal. And next one, coming to the read and write. Read would be low whenever you are going for reading an operation from the memory. For example, you are reading a data 78 from the memory location. So the opcode fetch cycle, this is an opcode fetch cycle. It will fetch a data from this memory and it would be read. And similarly, you are having write operation. Write operation, this is not performing any write operation, so it is write operation is every time high. And whether it is a memory operation or IO operation, it is a memory operation. That's the reason it is low or throughout the operation. And here, the 4 clock bus, as we have discussed, it could be used for refreshing cycles or something like that. Or if the data may be extended, it may be read up till the 4 clock cycles. This is the example of an opcode fetch cycle. Now coming to the next example, MVI A, 45H. What else you will be having in this one? In this timing diagram, I mean to say, in this example, you will be having two things. One is an opcode fetch. Opcode fetch is nothing but taking a data from the 45 into the A. That is the work has to be performed by the microprocessor. And then next one is immediate value, or we need to take this one 4 5 and need to reload it. So both are, one is an output fetch. Output fetch is 3 gate, and one more is read operation. So these two read operations, this memory read and output fetch, these two operations are there. That is being shown in this waveform. So anyhow, once again, we will have a discussion about how the memory read operation will be there. These are the two waveforms: fetch cycle and the memory read cycle. Next one is here you are having a total bit address. Again, it is a memory read operation. After fetch is 21, and memory read is nothing but given as the first value and second value. So for this one, we'll go for an example that's shown over here, and how the execution. The first one, after fetch, read and memory data for the, what is the memory address, and read and higher order memory data for reading purposes. A similar timing diagram is being shown over here. After fetch cycle, memory read cycle, memory write cycle, memory read cycles, and after fetch cycle. This is overall and the basics of your timing diagram, how a timing diagram has been developed. Next one, how a read data and how a write data would be discussed in the next video. So please keep watching this video, and if you are having any queries, let me know. We can clear it up. Thank you, everyone.